If it was e times 1, I'd write this. It'd be quite
Or
close
you
to
could write e x1.
Oh, I could do this.
There we go.
E raised to
Zero.
0.1.
There we go.
All right, so those are pretty simple. Now we can get into the next section, which is more fun. 3-3.
No. Why are we going through another section?
Because that one's boring.
No, it's not. It's
Oh, I
fun.
kind of like it. We can go back.
This is much more interesting.
I don't like this. Why are we gonna? Okay. I
Why are
really
you
want to
waiting?
do a section at a time.
College. Get used to it. So let's start off with, how do I want to start this? Let me think for a second. Log base b of x is equal to m, and log base b of y is equal to n.
N equals n.
No, they don't equal each other because x and y don't necessarily have to be the same.
B m equals y.
All right. What is the alternate forms of both of those?
B m equals x and b.
Say it proper. I mean,
B
b
to the n equals x.
raised to the n power is equal to x, and this one over here is
B to the n equals y.
b to the n is equal to y. Okay.
Maybe you didn't, Sam. Who's the genius, Sam?
You had b in
No one.
like thousands.
Mary Catherine. Yep.
Yeah, no one.
Really?
No one hears
I heard
me.
I didn't hear you.
So what if I did log base b of m times n?
It would be x, y.
Well, what can I replace m? Oh, wait a minute. I'm sorry. You're right.
Huh?
X, y.
Oh!
Let me back up. I chose the wrong variables.
Mary Catherine's right.
Mary Catherine was doing something else. You're giving me the answer.
Mary Catherine.
Log base b of x times y. Log base b of x
It
times y.
would be m
Well, x is equal to
m.
b to the m, and y is equal to
B to the n.
b to the capital N.
So it's B to the
So
n
it would
times
be m
n.
n.
B to
Careful,
the n
careful,
times
careful.
n.
Base times base, what do you do with the powers?
You multiply them.
Base times base, what do you do with the powers?
Add
Add them. So this is b to the n plus n. Okay.
Yep, that's what I said.
So it's a nice manipulation up to that point. You take log base b of x times y, it becomes log base b of b to the n times b to the n, and then the bases come together to give you b to the n plus n. Why do I want to do that?
I don't know, make us really confused and make our head hurts.
Not yet.
Our head.
That's coming.
Our head, sorry.
Why I did that was now I have these two b's right next to each other. One's a log and the other one's a exponential. They go poof, and what are you left with? N plus n. So this equals n plus n. Log base b of x times y is equal to n plus n. Great, except that means absolutely nothing.
I'm
Because-
confused.
The left-hand side has xy, and the right-hand side has m and the n. But n is equal to this m
Yeah, equals
is the
log.
same as that m, which is equal to log base
Oh
b of
my
x.
gosh, what are you doing?
You'll see. So you get log base b of x times y is equal to log base b of x plus, what's n equal to?
I don't know.
This headache you're giving me.
Carry it back up.
Log base B to Y.
Log base b of y really loud from the back row.
That's Bridget.
Go Bridget.
Arnie.
This is the product rule for logs. If you keep doing that, you might actually get your brain to work.
Oh.
Got your attention, didn't I?
Product rule
I like
for
that.
logs.
Product rule for logs. The-
Alright, next time you hit your head with the book, that's what I'm gonna tell you.
I don't want to.
Oh, it's not
I will
me, was
never
talking
hit
to
my
Sam.
head with a book.
I was talking to Sam.
Oh.
Does it matter how we write
She's done
log?
it before.
So,
Don't call me.
log of a product becomes the sum of their logs. It's actually really kind of a neat law.
Does it matter how we write log?
LOG.
I don't want points taken off because I didn't write it right.
LOG.
Why would I take it off?
Well, 'cause, like,
As long as you spell it correctly, I'm happy.
I didn't know if you
Can't
had
spell
If you
Log.
cannot spell L-O-G,
No, I didn't know.
Oh.
I didn't know.
Marty.
if you want to write it that way, that's fine.
Okay.
It's better with the curly because that sometimes can get confused with one.
No, it can't. Yeah.
Oh, I've seen people confuse it with one.
Not if you do one like this.
Oh, yeah.
Like the calculator does it. Or not the calculator, the computer.
So, with this log,
Oh, shoot me.
I can take this ugly expression
Oh.
and I can expand it. I could break it up into smaller, I could break it up into separate factors.
You can.
So, it basically works out,
Oh, that's
Wait,
49.
before you start going further, Sarah, let me copy down the original.
Yeah, wait, we can.
you could just do 49 x. 49 x.
Okay, so, you know how that property over here, you said x plus y, so would that be log?
Log of x plus log of
So-
y.
Would it be log base 7, 49x plus
Well, you could, yeah.
log base 7?
No, I don't. Oh, that's what it is. Oh, logarithm.
Plus log base 7, y plus 3?
Yep.
Is that what it would be?
That's part of it. Almost done.
Log of 7 of the 49.
Oh, you be quiet.
Oh,
Oh my
Sammy
God,
Joe, let
Sam.
me copy this down, girlfriend.
She doesn't.
Yes.
Oh, you're done.
Yes.
Now,
Sammy Joe.
you got to remember, between here is also a times.
Times.
So you could separate that too.
Oh, so it could be log base 7 of 49, log base 7.
Well, say it right though.
Wait, so it isn't
Log
49
base
x?
7 of 49 times plus.
Plus.
Okay, wait. Log base 7 of 49 plus log base 7 of x plus log base 7 of y plus 3 because it can't
Now,
do anything else.
Can you separate the y plus 3?
No.
No.
It doesn't times.
Because the law only works when there is
Multiplication.
multiplication.
And division.
Does not and division, but multiplication and division
Wait,
are
so
the same property.
49x?
Yeah, you separate the 49 and the x.
Ah, now what's log base 7 of 49 equal to?
7, 2.
2.
So
It's
you can
literally equal to 2. So this is 2 plus log base 7 of x.
I thought that wasn't
I
together though.
circled the answer.
Oh.
Equals.
That's the proper answer.
Oh my god.
Anytime you can simplify, simplify.
Okay.
Wait,
So we can split up all of that.
With products, only products so far. So if they're multiplied together, you can separate them as two separate logs. If they're added together, you can't do a darn thing. What?
Can you put it in exponential form?
What?
Can you put them in all into exponential form?
Why would I want to?
I got a
Why?
question. Yeah, why couldn't you just left that as the...
Oh, up here?
Yeah, uh-huh.
I mean, there's reasons to leave it this way, and there's reasons to separate it out this way.
Told you to expand.
In
Why?
calculus, you don't want to see it this way
Why not?
because it's horrible.
It looks fine to me.
This is much easier to work with because they're separate little pieces and you could deal with them individually.
Okay.
Calculus is a bear. It's not very much fun. Well, for me it is. For you guys it won't be.
I'm taking it online next year.
I'm offering it right after this class in the summer.
I'm not taking it a class in the summer.
What?
Absolutely not.
Babies. All right.
God, you think I'm crazy?
How about this then? If you have log base b of x over y. Log base b over x over. Let me give you a little hint. If you have a to the x times a to the y, what happens to the powers? You add them. It becomes a to the x plus y. Remember, logarithms kind of say get rid of the base and just look at the power. So the log of a product becomes the sum of their powers, if you want to think of it that
So
way.
that'd be subtraction. B
This would be
minus
subtraction. So this would be log base b
minus
of
x
x.
minus y.
Minus
log base
B.
That's what I'm doing.
Every time you separate, you have to add in that log every time. So don't skip it and just put a minus sign in there because log base b of x minus y is totally different than what I
What's
just did.
that? Right, so that's like
last year
division.
now.
It's minus instead of plus.
What's that?
Division.
Division is minus instead of plus, yeah.
Okay.
Same idea though.
So this is the division
Quotient.
rule.
Quotient.
Quotient rule.
Quotient rule. Log quotient rule. All right, that leaves one last one, but we'll get to that in a second. For example,
Or we could get to it tomorrow.
It's almost quiz time.
It is quiz time.
it's not quiz time.
Yes, it is.
One more
Let's
time.
No.
Get it over with.
Oh, pinch me.
I have Quidditch practice.
What?
Did you just say Quidditch? Okay, Harry Potter.
My
No,
cousin
it's
actually had
Hermione.
Quidditch
It's
team out of
Hermione.
school though. So I,
She's Hermione.
Hermione.
yeah, at Cardinal Games they have
What's
a
that mean?
Quidditch.
Wait, is that-
team
What is
out there.
Quidditch?
What is that
It's
two?
Harry
Say
Potter.
Hermione. Z.
I like
No, the other one.
2. The one I
Just
just
erased
erased. They're all base 2. The other direction you can go with this. This is called contract.
Are those all base 2?
For this class, this one's much more interesting.
I like this
For calculus, you want to expand them. For our class, we want to
one.
contract them. So here's the way you do it.
I hate cards.
Minuses go to the bottom. Positives go to the top. And if you keep that straight, everything works out. You write down LOG once. You write a fraction. When you put these things in here, there is no addition, no subtraction. It's all multiplication and or division.
It would be x times 2x
Wait.
plus 3 over 7.
The positive ones are the x term.
Is that, is log, is the middle log a 2?
Base 2, yeah. I touched it with my finger and it kind of went away.
You said one
So,
more.
X goes in the top. What else goes in the top?
2x plus 3.
The 2x plus 3. Drop the log because you only write it
Over
once.
z.
So this becomes 2x plus 3.
All
All over.
No, that's how you're expanding if you're contracting.
Z. When you contract, you want to write it as one logarithm. When you expand it, you want to write it as multiple.
Why don't you put the z and the 2x plus 3 together?
How can you put the z and the 2x plus 3 together?
Because they're next
You
to one another.
can't.
The z's in the bottom. It's negative.
It's negative Z.
So he gets dropped.
So,
Okay.
oh, I get it! I know that, but since the 2x plus 3 is next to the z on this side, shouldn't it?
Addition is commutative. You can put them any which way you want.
It's quiz time.
I can move the negative z way out here. It has nothing to do with that 2x
I have a
plus 3.
question.
Does that make sense? What?
It's a weird question.
Oh, no, I don't want
No,
to.
no, no, I have a question. Come on.
Yay!
Please.
Quiz time.
Please, no, come on.
Yay!
What?
Okay, what if it was like
What?
x times 2x plus 3 over z over something else?
Hey, Sam.
A complex fraction. What would you do?
You mean log of a complex fraction, or
No, like x, like all that you just wrote over like w.
It don't matter, right?
analysis? Okay, so let's continue with 3-3. Which covers probably the most important section in the book, property of logarithms. And we had one law which said the log base b of x times y is equal to log base b of x plus the log base b of y. When you write equals, it means you can go both directions. You can either move left to right and separate them, or move left to right to separate them, and right to left to put them back together. So when you see an equal sign, don't read it as left to right. It's always back and forth. Law number 2 that we handled yesterday was log base b of x over y, and the only thing that changed is a subtraction. It's like a base over a base. What do you do with the exponents? Because remember, these answers are exponents. So here you would expect your exponents to add because your bases were multiplied. Here you would expect your exponents to subtract because you had a quotient. So it has some interconnection to properties of exponents. So we need to come up with the third law, which is probably the most powerful of all of them.
Powerful?
The power one. So what we're going to do is we're going to look at what happens if I have log base b of x times x, better known as x squared.
It's gonna be x.
Well, it's going to be log base b of x plus
Log base b of x,
log base b of x,
which is gonna be 2 log base b.
which gives you 2 of them, because when you do multiple additions, it turns into multiplication. So you get this. So originally it started off really as log base b of x squared. So what happens is the exponent kind of lands in front. So you can take exponents and bring them down from an exponential position and make it a regular old number. See, this is a power of 2, this is just plain old 2, which is nice. So the law basically says this: if you have log base b of x raised to the power of p, then this becomes p times log base b of x. It is a very, very useful little law. For example, back to this formula.
I hate this formula.
I know. That's why I'm going back to it. It's really important. I mean, that's how basic banking works, compound interest.
I'm not going to be a banker, so it
Doesn't matter.
not
You're going to
matter.
make money, right? You want to learn how to work with money, don't
That's
you?
what an accountant is for.
That's what an accountant is for. Sure, if you're filthy rich. Let's say I know I start off with $150. So I start off with $150, I deposit it in the bank. I want to know when that money triples.
What?
I want to know when that money triples. Is that 450?
Yes.
Yeah. 2 is 300, 450, yeah. So I want to know, how long is it going to take this money to triple in value? The rest of the problem is at 5%, compounded monthly, and the problem is, I don't know how many years. How would you solve for t?
You would do a lot.
Eventually.
You said try, I'm not trying to divide them.
You,
Divide.
Hold up.
What is
Divide
that?
the 150 over.
Oh, divide the 150 over. So you divide both sides by 150, get those parentheses by themselves. This side becomes, miracle enough, 3. 3 times as big, is equal to, now, what is 1 plus 0.05 divided by 12? That's just a number, so what is it?
Wait, what?
1 plus 0.05 divided by 12. For those that don't have a calculator, oh well.
Can I use my pen for my calculator?
1.00, is that it? Just 4 and it stops.
Oh, 1, 6, 6, 6, 6, 6.
4, 1, 6 repeating. Raised to the 12t.
So
Ah.
did you get the 0.05 you just pulled out of nowhere?
I said it was at 5% interest rate. 5% interest rate. Compounded monthly. Alright, so now I have this equation. Now, can I subtract the 1.00416 to the other side?
No.
Can I divide it?
No,
No.
because it,
It's stuck with this power up here. So I need to change that power away from being a power. So the only thing that can do that is a logarithm. So what you're going to do is log both sides. So you're going to log it, log, regular old log. What's the base of log?
110.
10. It's automatically 10. You could do log base that, but that gets ugly.
Couldn't you do ln also?
You could, but I'm not going to get into that one yet. ln is more useful for other things. So you're going to log this side, you're going to log the other side, and you're going to see what happens. So if I log this side, it's log of 3. Boring. This side, it's log of 1.00416 repeating forever and ever, raised to the 12t. But the cool thing is, what can I do with that 12t now?
Bring it to the front.
I can take the whole thing, since it's an exponent, bring it to the front.
Is 12 on the inside of the parentheses? Yeah.
Yeah, it's inside the parentheses. I just ran out of room. So this side becomes log of 3, and this side becomes 12t times log of 1.00416 repeating. We'll decide how many decimals we need, or how many our calculator will take. What am I trying to solve for? T. So how do I solve for t?
Divide by log and 12.
Divide by the log piece and the 12 piece. So divide by 12 log 1.00416 repeating on both sides. Now, do the logs cancel?
No.
I've seen people do that. Can you take 3 and divide by this number and then take its log?
No.
No. So you can't do log of 3 over this.
Can you
So-
do anything to it?
The only thing you could do to it is type it in your calculator.
Wait, why wouldn't you divide that?
Yeah, you have to do the 12. You have to do the 12.
Oh, I forgot the 12, sorry. So, don't do anything fancy with the logs. There's nothing you can simplify on the left-hand side, so you have to type it directly in your calculator. But, when you type it in your calculator, do it in one step. But you need to remember to put a parentheses before the 12 and after the log. Because you're dividing by a product, and if you type it without the parentheses, it only does one of the number division, the other one becomes multiplication. So, type it in, tell me what your answer is. Where is it?
22.
How you doing?
$10.
I'll have some dollars.
22.
So sorry.
Yeah.
Okay, then there's your 22.
How do you work this thing?
You work this thing. You push numbers into it. LOG's on the left-hand side. Hit 3. Make sure you close the parentheses after the 3.
I know how to work it now. It's
Okay.
just I don't use this calculator.
It's the same as the TI-83. It's just different positions for some of the buttons. So you get T, approximately
22.
22 years, and you
Hold
can
on.
triple your money. So that last one becomes really, really important for solving exponential equations when the variable is up in the exponential position. 22 years. 22.0 something or other.
22.1. If you want to divide it.
02.
All right, so let's go back to what we were trying yesterday, expanding. And I want to expand log base 2 of the square root of x times y minus 1 over x plus y raised to the third. Why not?
This looks fun.
It's gonna be neat.
Now, when they start getting a little bit more complex, you can pretty much still determine if it's going to be positive or negative, a plus or a minus. But when you start getting radicals and powers, it starts getting a little confusing, especially if those powers go over more than one product. Like, for instance, this top square root will get a little confusing if you don't do it properly. Highly suggest, change the square root right into a power.
So it would be 1/2.
Yeah, you want to change it right into a half. If it's a cube root, you want a 1/3. If it's a fifth root, you want a 1/5. So if you get into that habit, things become a little bit easier. So log base 2, and if you have a square root of a product, can't you separate it? Because you want to keep these terms as separate as possible. So write it as x raised to the half, y minus 1 raised to the half, over x plus y raised to the third. This part here is using the rule that the square root of AB is the same thing as the square root of A times the square root of B. Assuming that A and B are positive numbers to begin with. So we're assuming that x and y minus 1 are positive values. All right, now what can I do?
Yeah, separate.
Anything that's in the top, positive. Anything in the bottom, negative. So this becomes positive log base 2 of x to the 1/2. Positive log base 2 of y minus 1 to the 1/2. Right? Minus,
Hold up.
stop it.
Do the second one right now.
Yeah.
Remember, this is a multiplication here.
Alright, and then
Minus
x plus y.
log base 2 x plus y raised to the third.
Could you put all the
Ask
one
for the-
1/2?
the thing.
We're going to. I was going to separate multiplication division first and then worry about the power second. So this becomes a half log base 2 of x plus a half log base 2 of y minus 1
Minus 3 base 2.
minus 3 log base 2 x plus y. Do not separate additions, do not separate subtractions within a logarithm. Only multiplication and division. That's the best you're going to get out of it. Now-
What about if you
Divide.
could
Huh?
That's not the answer, right? Wouldn't you divide?
do
Division turns into subtraction
Oh, yeah.
because of this law.
If you take off points if we don't put the exponents in front?
Uh-huh.
Okay.
That's double point.
You have to do everything here as a law to rip it down and stretch it out as long as possible. So when you think of expand, you want it as long as possible. You don't want to try to keep it short, which is what math is usually about. All right, let's go the other direction. Contract.
What about if you could? No, I'm not gonna ask it.
Go ahead.
Like if it was
log base 2 x squared. No. I'm trying to think.
What if I had an 8 in here?
Yeah.
Then you would have this 8 here, right? Then it would be log base 2 of 8 plus the rest of it, right? What's log
Can't
base?
you simplify log base
Yeah.
2 of 8?
That would be 3.
And you want to see what happens? Okay.
Yeah, you see something like square root of 8, you have to simplify it into 2 square roots of 2. You see something like log base 2 of 16, you better change it to 4.
Do you take points off? Do you put parentheses? Like parentheses?
Oh, here? Yes, because log base 2 of y minus 1 is totally different than log base 2 of y minus 1.
Yeah.
If you're thinking graphically, what does this minus 1 do?
Yeah.
Drops the graph down 1. What does this minus 1 do? Moves it to the right one. They have 2 different effects. So yeah, you need those parentheses around there. I highly suggest putting parentheses around all of them. So you can say log base 2 of x. And you start thinking of these parentheses as a function rather than times. Because I've seen someone solve a problem like this. Log of x equals 10. X equals 10 divided by log. I've seen that. It's scary. I'm dividing by Frank. Add. Contract. Oh, this? 10 to the 10th power. 10 to the 10th power is the answer. Because if you change it to an exponential, it would be base 10 raised to the equals, so whatever the heck. So it would be 1 with 10 zeros after that. Were you from Hawaii or something? Hang loose. Alright, so what should I do first? To contract these.
Your powers up.
Take all your powers and put them back in their proper places. Don't worry about the sign. I mean, you could make that a negative 1/3, but it's best to leave the minus sitting there for now.
Are they all supposed to be log base b?
Oh yeah, log base b.
Hold up.
You can't mix logs. That's the question I was waiting for.
Like,
I was waiting to see if someone would say, is there a difference between log base b and another log? Can I combine them? And the answer is
No.
absolutely not.
Just like power.
absolutely.
Yeah, just like powers with different bases.
So
You just
if
can't touch
you
it.
have two different logs or two different bases, whatever, you just leave like it is.
You just leave it like it is. If you have log base 2 of x plus log base 3 of x, you can't do a darn thing. It's like square root of 3 and square root of 2, you can't add them together. Alright, so bring the powers up so you get log base b of x minus 1 raised to the 2/3 power minus log base b of y plus 1 raised to the 1/3 power plus log base b of z raised to the half power.
Did you just square root the z?
You could write it as square root, but there's something I want to show you with this one.
No square root.
Alright, now once you get into this type of setup, you can write log once, log base b, write a fraction because there's pieces that are going to go in the top and there's pieces that go in the bottom. What goes in the top?
X minus 1 and z.
X minus 1 to the 2/3,
And then z.
z to the 1/2. What goes in the bottom?
Y plus 1 over 1/3.
Y plus 1 to the 1/3. Now, this is actually kind of messy because there's way too many ugly fractions. Is there a common denominator between all those fractions?
6.
6. So what you want to do is you want to change these all into 6. So this is 4 6,
And that's 3 6.
3 6,
And 2 6.
and 2 6. Once you do that, every one of the powers has the same base in the bottom, which is 6. So a better answer, I mean, this would be fine for the test. I'll give you full credit for this. But the back of the book might actually have this answer.
I'll stick with the first one.
But this one turns out nicer on the inside. because they're all whole number powers. You see what happened?
Yeah.
I took the 6 power away from each of them and made it a big old 6 root. And then what was left was the 4, the 3, and the 2. This is a much simpler form. So if the book asks you to do this, more than likely they're going to have this as an answer. Or the whole thing raised to the 1/6, one of the two. This is just a nicer way to write that mess. Does that make sense?
Mm-hmm.
Yeah. It's just that common denominator thing.
How do you know when what goes on the bottom again?
It's negative. If it's negative, it has to go on the bottom. Like a negative exponent. Needs to go down.
I mean, like, what if there's like 2 different logs? Like, when I first saw that, I thought the log.
That's what I'm saying. If it's log base 2 and log base 3, you can't touch it.
No, I meant like right there, like log base b of y plus 1 plus log base b of z. I thought those 2 went on the denominator together.
Yeah, but this one's negative. You're thinking it of as this,
Yes, kind of.
but it's not that. Then these 2 would go in the bottom
Is that
because they're both
Negative.
negative. But without those brackets, this one's negative, this one's positive.
Okay.
That negative doesn't carry all the way over.
I have a question. If you have, this is just a random question. If you have x minus 1 like, to the 2/3 power, whatever, would it be the cube root of x minus 1 squared?
Yes,
Okay.
definitely. And if you want, you could write it that way. Wouldn't hurt it. But then you kind of lose the fact of what's the common denominator. It gets a little harder to get to this.
So what's wrong?
Yeah. I mean, it's up to you. On test day, I'm happy with that. If you can get it together and get it in those pieces. The rest of it is, what do you call it?
Irrelevant.
Making it look pretty. Quick word for making it look pretty. Aesthetics. Aesthetics.
Critiquing it.
Huh?
Critiquing it.
Critiquing it. Boring.
Yeah. Ooh. We're not teaching that.
Change of base. Semi-important idea. Our calculators only work in base 10 and base E. LOG and LN.
I thought you could change
No, mine works somehow.
it. You can change it.
Those things have a special feature which you can tell what the base is. It's log B, and then you have to put in the number or algebraic expression, comma, what base it's in.
You can divide
Yeah, I think that's what you got. You can divide it.
Yeah, I think that calculator actually has a function that'll do different log
it.
bases. I'm quite sure. You don't need it though. I mean, it's so simple, it's funny. So if you have log base 5 of 38, and you want to evaluate it or approximate it, the first thing you do is, well, I'm wondering what that's equal to. So you call it x.
Alright.
And then we start cranking through all the possible properties we can come up with. Since we don't know what x is equal to, and we're working with a log, what's the other option I have? Change it into an exponential. The base is 5. It's raised to the, and it's equal to 38. But now we're back to the problem of, I really want to solve for x. So how do I solve for x?
The fifth root.
Fifth root.
Third. No, that's not. I'm sorry.
The fifth root? No, that's
I'm
not going to
sorry.
work. The x root of, yeah, that's not going to work.
But-
What's it? How did we solve for the exponential before? Do the log. Now, we have a choice. We can do LOG.
Well, why don't we just keep it in that and then put it in?
You can't put this in a calculator.
Why not?
Okay, there's 2 buttons on there for log. LOG,
No.
and the base, it's in there, right?
10.
Yeah, you can put the
Base is 10.
You can change the base.
But it doesn't allow you to change it. I'm trying to come up with a formula for it.
It won't show you how to do it without it.
I'm pretty
No,
sure
that calculator that you have in your hand
This
does
one won't.
not change base.
This one won't, but my other one will.
Woohoo! He's got the answer.
Yay.
Now let's find out how to do it with every calculator. So, you're going to ln or log both sides. So I'm going to ln. Why?
You just want
Because
to.
then you don't have to change the
No, because I'm lazy. Log takes 3 letters and ln takes 2.
Wow.
So ln both sides. Mathematicians are
Lazy.
generally lazy. They want to find the quickest way to do something. What happens to the x now? Comes out front, so you get x ln of 5 is equal to ln of 38. Can you solve for x?
Yes.
Yeah. You get x equals ln of 38 divided by ln of 5. And you type it in your calculator and you get your answer, which should be 2 point whatever. If he did this right.
Yeah, whatever. 2 point what?
I don't know, he came up with 2.3.
126.
2.6?
2.26.
2.6. Did it came up that way?
Hold on.
2.26.
2.26. Approximately now. This is not exact. The exact answer is actually log base 5 of 38. That's the exact answer.
2.26015.
It goes on forever. Please. Irrational number.
So how do you know when to do log and when to do lambs?
Yeah.
You could do either or. This formula works the same if you went log of 38 divided by log of 5. Try it.
Why did that come out the same?
Now that's harder to explain. Because I can do the same process with LOG and come up with that answer. So if this is the
Please
answer
don't
and
explain.
that is the answer, they both of them must be equal to each other.
But my question is like LN's base is E,
Yeah, I
and that one's 10, so,
I know.
and they're not the same thing.
The same ratio though.
Why?
No.
Do we care?
It
He
works.
tells us.
Like I said, you can go through this whole thing with LOG, come up with this one. Since you come up with this one and this one, they must be equal. They look different, but they're definitely equal.
So you don't
Basically, they have the same ratio.
eat and
So
do
proportion-
you
they're
care
proportional.
which one we use?
No. I like LN.
LN is to eat.
Most people like LOG. I like LN. It's just me.
LN.
So formally,
Ellen DeGeneres.
the formula, I like writing this way. Log base b of b is equal to. It's up to you if you want to write this.
I am.
Log of the big one divided by log of the small one. And what I mean by big and small is the one that's written big and the one that's written small. So I write it that way. And you can always replace LOG with LN. That doesn't matter. So this is the change of base formula.
But you can't make some candy.
No, you cannot mix LN and log. They have to be one or the other.
Oh, I just did that.
Oh, I just did that. Great. Ah. So if I write, just curious, if I write log of 13 divided by log of 7, what does it equal as a single log?
Log base 7, 13.
Just curious. Log base 7 of 13. Ah, alright. What else is it? Change of base, boring. That's it. How exciting.
First time.
What time is it?
Quiz time. Is it time?
Yeah.
Oh, yeah, I doubt it. Heck no, it's only 2 o'clock.
Yeah.
Dang.
Next part's not too bad. We already did some of it.
Would you do one where you don't have to use the mixed bases?
What's that?
You have different bases.
It's
You
gonna
do
give
one
us
like that.
free time.
Do what?
Where they don't have the same base.
If they don't have the same base, you can't do anything. That's what I'm saying. If you have
Jose?
Yeah.
log
Just-
base 2 and
just
log
see
base
one.
3,
Oh,
you're kind of stuck. It has to either be one or the other. I guess we could use the change of base formula to force them to do the same.
Do it as you should.
What? What'd you say?
I'm thinking, oh, that would be horrible. Ready?
What'd you say?
Log base 2 of x plus log base 3 of y.
You can't do anything with it.
Yes, we can.
Actually, you can change it and make it like a common denominator thing that you were just talking to, or common
I'm just
factor.
curious.
Fruit spray?
Because we could change this. Oh, this ain't a fruit berry. If we use a change of base formula, what does the first one become?
Log base.
That's
X.
headache. Log of x over
Log 2.
log of 2 plus
Log of y. Log of 3.
log of 3. Now, log of 2 and log of 3 are just numbers.
Oh.
They're just numbers, literally. They're like 5 or 2 and 3, literally.
I'm passing this.
You could type it in your calculator and come up with some ugly decimal answers for it. Hold on.
Okay.
So this is the same thing as 1 over log of 2 log of x plus 1 over log of 3 log of y. Remember I said you couldn't do anything with it? I lied.
Oh, no, keep it simple.
Yeah.
No.
Now, 1 over log
Are
of
we gonna
2.
need to do this?
Yeah, we could do this. 1 over log of 2 is just a number. Where does it go? It goes up here.
Yeah.
At the same power. So this becomes log of x raised to the 1 over log of 2 plus log of y raised to
1 over log of 3.
1 over log of 3. So then it's addition, so what can I do to my pieces?
Multiply.
Multiply, so you get log
God.
of x raised to the 1 log base 2, y raised to the 1 log base 3.
Can you make it so that it's the square root of log base 2?
Not yet, no, I
The
don't
log
want to.
base 2
I
root.
really don't want to. That's as bad as it can get. So yeah, you can use these laws on anything.
God.
Different bases, same bases, it doesn't even matter. Because of the change of base formula. Another thing that might be possible, ready? If you have 5 to the x, I want to change it into e to the u.
I don't have 5 to the x though,
Why?
so.
Why not?
Because it's ugly.
No, it's not. Actually, this is ugly, this is nice. And I'll give you a hint.
What are you saying now?
This is ugly. In calculus, this is ugly.
Really?
This is nice.
Everything is beautiful inside.
Right.
Maybe it has a kind heart.
Now, in calculus, 5 to the x is a horrible thing to work with, but e to the x or e to the u in this case is really simplistic. I'll give you a hint later on. You won't know what the heck I'm talking about, but I'll show you how ugly it gets. All right, so how do I change 5 to the x into e to the u? Well, you set it equal to each other,
Ellen?
and you're trying to find what u is equal to. So you ln both sides. When you ln this side, it becomes x ln of 5 is equal to
You.
u. So I've actually found u pretty quickly. So 5 to the x is the same thing as e to the x ln of 5.
Huh?
Cool.
Look, look, look. If I take 5 to the x and set it equal to e to the u, if I ln both sides, you get the x comes down, ln of 5. When ln and e run into each other, they go poof and you're left with u. So I solved for u, I got u is equal to this. So it's e to the x ln of 5.